Alrighty, we have a video lesson here on formulas and functions, and you should know how to solve an equation for a variable using numbers. And once you can do it using numbers, then you should be able to do it when all we have are variables. So we'll start out with something simple here. It says the area formula for a rectangle is A is equal to L times W, and A stands for area, L, and remember that this is a lowercase l and this is a lowercase w while this is capitalized. We need to make sure that we pay attention, and if they're capitalized in the formula, keep them capitalized. If they're lowercase, then they stay lowercase, because there's different parts throughout math and science and just other parts of life where in formulas you'll have some of the same letters. It's just some will be capitalized and some will be lowercase. So we need to make sure we keep things straight with what we're using. So L equals length and W equals width. Sometimes you might see B and H, base times height, for the area of a rectangle. But we are supposed to find the length, solve for the length. So if we know area is equal to length, and when I do a lowercase l, I put it in cursive so it doesn't look like the number 1. So area is equal to length times width. Well, how do we get L by itself? Well, we know L is on the right side of the equal sign. And what is happening between L and W? That is multiplication. So what's the opposite of multiplying? That would be division. And what are we multiplying L by? We're multiplying L by W. So then we should divide both sides by W. And we know from our number sense on fractions is that W divided by W will cancel out, leaving us with 1. And so therefore we have L left on the right side. The length is equal to area divided by width. And that's what L is equal to. That's what the length is equal to. So you do have to have some strong equation solving skills here, because there's no numbers to work with, no calculators to use. In this example, the area formula for a triangle is A is equal to 1/2 base times height. You could also have used the formula for a triangle, area is equal to base times height divided by 2. Those are the same formulas. Solve for the height. If you feel confident in doing this, do so. If not, pay attention. Area is equal to 1/2 base times height. Solve for the height. Well, we need to get h by itself, and h is on the right side of the equation. So how do we get h by itself? Well, we know that we are multiplying h by 1/2 and by b, or the base. Well, first off, let's start. How do we get rid of multiplying by 1/2? You may said divide by 1/2, but remember, when you divide fractions, you're really multiplying by the reciprocal. And the reciprocal of 1/2 is 2 over 1, which 2 over 1 is just 2. So these cancel out here. And we are left with base times height is equal to twice the area, or 2 times the area. And how are we trying to get? We're still trying to get h by itself. So right here we are multiplying h by b. How do you get rid of multiplying by b? You divide by b, so they cancel out. And if you divide the right side by b, you also have to divide the left side by b. And so our final solution here for the height of a triangle is equal to twice the area divided by the base. So there's one example there. Actually, that would be the second example, wouldn't it? Okay, so those are some area formulas and reworking area formulas. Now, we are going to be working a lot with equations. Coming up, we're going to be dealing with equations and graphing lines. And you're going to need to know how to change those into different forms. We're looking at this equation 2x plus y equals 5. That's in standard form right now. And it's going to be pretty simple to change this to slope-intercept form. And once you get it in slope-intercept form, it's pretty easy to graph. But let's look here. We have two examples. What is different between those two? What are they asking us to do? Up here at the top, rewrite the equation so that x is a function of y. And down here at the bottom, rewrite the equation so that y is a function of x. And you notice how this is the only difference between the two examples. Now, it's something so tedious and so small that if you get in a hurry, you may forget about it, and unless you really pay particular attention on what you're supposed to be doing, you may be solving for the wrong variable here. So when it says x is, go back to your verbal model. This is a good indication. When it says x is, well, we know we are going to be looking for an equation that's going to say x is equal to. So in this first example here, when it says rewrite the equation so that x is a function of y, we're looking to get x by itself. Down here, if we're trying to get y as a function of x, what are we trying to get by itself? We're trying to get y by itself. Y is a function of x, so you should have y equals something when you're finished. So you have to pay attention to what it is actually asking you to do. If you get in a hurry, you may actually miss out on what it's really asking you to do. So let's go to the first part. We're trying to get x as a function of y, so we have to get this x by itself. So let's see here. Multiplication does not come before exponents. So this is our order of operations. If we have all of the values of an expression, we're able to solve it out and figure out what it's equal to. But here, we do not have all of the variables here. So in order to solve for, in this case, we're solving for x. Anytime you're solving an equation, you're always working backwards through your order of operations. So let's get rid of the addition and subtraction stuff first. I see multiplication between 2 times x, and then I see addition between 2x and y. So what are we trying to get rid of first? If we're trying to get x by itself, we have to get rid of the y. And remember, if you subtract y from the left side of the equal sign, you should also be subtracting y from the right side of the equal sign. So let's drop down 2x. 1y minus 1y is 0y, which is just equal to 0. Drop down your equal sign. Now what is 5 minus y? Well, y has y with it, and 5 does not. So those are not like terms. So we are going to say 5 minus y. You could have also, if you wanted the variable to go first, y was negative, so you could have said negative y, and 5 was positive. So negative y plus 5. Either one of those would be correct, as long as you pay particular attention to your signs. Okie dokie, so from here, we've gotten rid of the addition and subtraction. Now we have to get rid of the multiplication. What's the opposite of multiplying by 2? That would be dividing by 2. dividing by 2. And so 2 divided by 2, and when we say cancels out, it really just reduces to 1. 2 over 2 is 1, and the invisible 1 is in front of x. We do not put the invisible 1 there. We leave it there as invisible. It's kind of like a superhero among math. It can turn invisible. It's like the chameleon of the algebra world. On the right side here, we have 5 minus y over 2. Now, we could leave it like this. That's one way to leave it. Or if you wanted to, break it up. This 2 goes underneath both the 5 and the y. That's also something you need to recognize, is that the 2 goes underneath both. So either one is fine. X can equal 5 over 2 minus y over 2, or x can equal 5 minus y over top of 2. But this one over here is basically the same way. You divide both things by 2. X would be equal to negative 1 over 2 y plus 5 over 2. And this right here is also equal to negative 1 over 2 y. There's just a couple different ways. Once you know your fractions, you're able to recognize that y over 2 is equal to negative 1/2 over y also. So I guess basically there's 3 parts to this, or 3 different answers you could have. Those 3. If you're doing a multiple choice question, you could possibly expect any of those 3 to be your answers. So that's why it's helpful to know all 3 different parts of that, how to break up that side of the equation. Okay, I'm going to erase some of this and then bring back our other example. So let me go ahead and erase some of this. And come back. Ah, there we go. Got her back. All right. So down here in this second one, we're trying to get y is a function of x, so we're trying to get y to be equal to something. Y to be equal to something. Well, if we look going backwards through order of operations, are we adding or subtracting anything to y? Well, you might think that, hey, I see a plus sign, so we're adding 2x to it. Well, that plus sign doesn't mean that we're adding 2x to it. The plus sign means that's a positive y. This invisible positive sign means that we are adding 2x to y. Because 2x plus y is equal to 5. If we rearrange this, wrong way. If we rearrange this, see your positive 2x, your plus sign is here, and your positive y, the positive sign is right there. So you got to remember to keep your signs with it. And so in this bottom one that I've just rewritten, y plus 2x equals 5, it might be easier for you to see that you're adding 2x there. So going back to the original, we have 2x plus y is equal to 5. So how do we get rid of adding 2x to y? Well, subtract 2x. And subtract 2x. And remember, we're subtracting 2x from both sides of the equal sign. 2x minus 2x is 0x, which is the reason why we usually cross it off, because 0 times x is 0, and 0 plus y is just y. Okay, and 5 minus 2x, they are not like terms, so then you put them together like this. They don't really get put together to make 3x because they're not like terms. You have to make sure you pay attention to this part. 5 minus 2x is just 5 minus 2x. That's how you simplify that. Really not much simplification there, is there? Okay, so I told you you're going to have to manipulate these equations to be useful here in the future, especially for graphing lines and some other things that we're coming to. But y equals 5 minus 2x, that's kind of helpful. But when we start graphing, especially in slope-intercept form, typically the x comes first. And so in this case, we have negative 2 in front of x. So y equals negative 2x. And what is 5? 5 is positive, so we're going to put plus 5. And this right here is slope-intercept form. I don't expect you to know that because we haven't covered it yet, but in the future I will. We know that this is the slope, negative 2. Negative 2 over 1 is the slope, and 5 is the y-intercept. And so this is why it's going to be helpful to be able to manipulate these equations so that y is a function of x. So from standard form, 2x plus y equals 5, you can graph it using slope-intercept form. Trust me, graphing is a lot of fun. And if you know how to graph, it's just a good time all around. So, learn how to graph, you just add a bunch of fun to your life. Simple as that. Okie dokie, so this one here says rewrite the equation so that x is, should be running through your mind, x is, we're trying to get x is equal to something. We're trying to get it by itself. So, there's a few things here. First off, we should always try to simplify first. In this case, we can distribute, because we need to get x by itself. There's a couple different ways to solve for x here. Distributing probably would be a decent way to do that. I think so, yes. So I'll show you this route. So if we're trying to get x is equal, let's distribute first. Okay, so now I just dropped down 5y. There's nothing we do there because negative 2 times x is negative 2x. Negative 2 times negative 7 is positive 14. And where are we going after this? We are going to try to get x by itself. Well, working backwards through order of operation, addition and subtraction, we are adding 14 to x, so we should subtract 14 from both sides. That leaves us 6 is equal to 14 minus 14 is 0. And what is 6 equal to? Well, drop down the negative 2x and drop down the 5y. Okay, so now we've gotten rid of one addition. Is there any more addition or subtraction happening? Well, yeah, there's this 5y. Now tell me, are we adding or subtracting 5y? Well, you might be in the habit of looking at this and say, well, we're subtracting 5y. Well, you have to remember that we're not subtracting 5y from 2x. That is a negative 2x. What is 5? Well, 5 is positive 5y. So are we adding or subtracting 5y to negative 2x? Well, we're adding 5y to negative 2x. So what's the opposite of adding 5y? That would be subtracting 5y. And we subtract 5y from both sides. And you notice how I kind of move the 5y off of the 6 a little bit? It's off to the side. And I do that because those are not like terms. And 6 minus 5y. is what we get there when we simplify that expression. On the left side, 5y minus 5y will give us 0y, and we drop down negative, don't forget your negative sign, 2x. Forget that negative sign, that'll be bad news. Okie dokie. Still trying to get x by itself, but we've gotten rid of all the addition and subtraction. Now, is there any multiplication or division happening? We are multiplying x by what number? What number was that? Yes, negative 2. We multiplied x by negative 2, so let's divide it by negative 2. And I'm going to split this up because what is 6 divided by negative 2? That's 3. And what is negative 5 divided by negative 2? Well, negative divided by negative is a positive. And then we have 5 over 2y. Typically, you'll see the variable off to the side of the fraction. You'll see the variable off to the side of the fraction. But you should know if you have 5 over 2 times y, that's y over 1, multiply the top numbers, you're going to get 5y, and multiply the bottom numbers, you get 2, which is what we just had right here. So 5 over 2 with a y off to the side is the same as 5y over 2. You have to be able to manipulate fractions like that. So this is what we have on the right side. And on the left side, negative 2 divided by negative 2 will give us a 1 and x. So we have rewritten the equation so that x is a function of y. Okie dokie, I'm going to erase this work so we can get back to the other example. Look at this. This is magic. Watch. No hands. You didn't even see it happen, did you? Alrighty. Rewrite the equation so that y is a function of x. When you see y is, you should be thinking y equals, which means you're supposed to get y by itself. So, in order to get y by itself, we still want to simplify if we can. Negative times a negative is a positive, and 2 times 7 is 14. Then drop down everything else. 5y equals 20. Now, if we're trying to get y by itself, what are we adding or subtracting to y? Well, we are adding 14. So the opposite of adding 14 is subtracting 14. Those will cancel to leave us 0. 20 minus 14 is going to equal 6. Now, in order to save you some space on your paper, what else are we adding or subtracting to y? We are also subtracting 2x. So let's add 2x. Leaves us 0x. Now, if I add 2x to the left side, I have to add 2x to the right side. So this will be plus 2x. 6 plus 2x, and we drop down 5y. Trying to get y by itself, we have worked out all of the addition and subtraction. Now let's get rid of the multiplication and division. In this case, we only have multiplication right there. 5 times y, which is the opposite of multiplying by 5. You guys are right on it today, dividing by 5. Now if I divide the left side by 5, I have to divide the whole right side by 5. And that means I have to divide everything by 5. And so, we now have y by itself, which y is equal to 6 over 5 plus 2 over 5 x. And make sure the x is beside the fraction bar if you are going to move the x to the side, because if you put the x down here, and your bar maybe extends a little bit closer to the x, it kind of looks like x is on bottom of the fraction, which would mean that we have 2 over 5 times 1 over x, and that is not what we have. In actuality, we really have 2 over 5 times x over 1. You see the difference between the two? So keep it in mind that the x will either go, and I'm not saying it's always going to be on top, but in this case, x is on top of the fraction bar, or if you move it out of the fraction, it goes right beside the fraction bar. Sometimes you do have variables on the bottom of fractions, so you need to just pay attention to what you're doing, use your math skills. This right here, y equals 6 over 5 plus 2 over 5x, can also be rewritten as y is equal to, this is positive 2/5 x, I'm going to say positive 2/5 x, and this is a positive 6/5, so that positive sign will look like an addition sign. Y equals 2 over 5x plus 6 over 5. So both of these are the same. You should be able to recognize that they're both the same. We do like this one. It is in slope-intercept form. But if we have this one here on the right, we can change it to slope-intercept form fairly quickly. Alrighty, let's get into a few other formulas here. This formula here will require you, this one is a little bit of a challenge. There's no numbers here at all, but we're asked to rewrite the equation so that y is a function of x. Well, when you hear y is, you should be thinking, what should you be thinking? Y equals. Okay, no numbers here, so how do we do this? Trying to get y by itself. The hardest variable, it seems, that I've noticed in the past of students to solve for is when one of the variables is on bottom of a fraction bar. And you just have to understand, fractions and what you're doing here. Well, how do we do this? Well, first off, I see that capital A there. I'm trying to get y by itself, so basically I have to get rid of t. Now, getting rid of t on top is a little more difficult. If it looked like this, all I would have to do is multiply by t. Those would cancel out, and it would just leave y. It would be really simple that way. But since we're solving for y and it's on bottom, we have to do some things first. Well, I see that this is an equal sign right here. And I know that I have a fraction and a fraction on both sides of the equal sign. Well, I can use ratios, cross multiplying and dividing. I can use ratios there to solve. But I cannot do it right now because of that a right there. So somehow we have to get that a into the fraction. So let's look at the right side of the equation. So we have capital A, and we are multiplying it by capital R over x. Well, how do you multiply fractions, right? Put this over 1. Multiply straight across. So we're going to get A times R, remember these are capital letters, over x, and that's going to be equal to t over y. We just drop this one straight down. And so once you know how to, once you use your fraction multiplication skills, you have simplified this equation. And so from here you can just use cross multiplication. Cross multiplication. You know what? Let me show you why cross multiplication works. T over y is equal to, we had AR over x. Why does cross multiplication work? Because we're trying to get y by itself. So I multiply the left side of the equation by y, and that cancels those y's out. If I multiply the left side by y, I have to multiply the right side by y. And so what do I get? I have t on the left side is equal to fraction multiplication again. Multiply the top. And then multiply the bottom. AR times y is ARY or YAR. Yar! That's what that is if you put YAR. Or if you put it ARY, that'd be like Ari. But you gotta put the little accent with it too. Alright. I'm going to leave it as YAR because because with multiplication you can rearrange these. Ray's an old friend of mine, or just any of these, because it's multiplication you can rearrange those orders, and that works for multiplication and addition. Back to where we are working. Back to where we're working though. So if I'm trying to get y by itself, I can multiply by x, right? Multiply both sides by x. The x's cancel, leaving us with x times t is equal to y AR. Yar! Trying to get y by itself still. So if we're trying to get y by itself, how do you get rid of a times r? Well, we could go, oh, we're going to divide both sides by a, cancel out the a's, or we could say, you know what? Since we're multiplying y by a times r, we're going to divide y, or we're going to divide the right side by a times r, so those cancel out. If we divide the right side by a times r, the left side also gets divided by a times r. And so now our final, since these canceled out, we have y on the right side. And on the left side, we have x times t over top of a times r. X times t over top of a times r is equal to y. And so you have rewritten the equation so that y is a function of x. And yeah, so that's where you're at. Well, that's all we have for this video. I would like you to see me tomorrow or the next day or anytime you want. Let me know if you have any questions.